Okay, a rectangular piece of wood floating in the water, right? So here's our fluid. It is floating with like that, right? With that much. What is the density of the wood? Oh, that's interesting. Okay, so what we know is that it's submerged. Okay, and we want to find the density of the wood. We know that the amount that it's displaced of this fluid, right? This is 893 kilograms per cubic meter. We know that that volume has a mass equal to the mass of the wood, because the wood is only going to float when it's displaced a mass of fluid equal to its own mass. Okay, this is Archimedes' principle, I do believe. Okay, so if I find that mass, which shouldn't be hard, I've got the dimensions, I've got the density, right? That will be the mass of the wood. So let's find the mass of the wood. Equals the mass of the fluid equals density times volume equals 0.13 by 0.152, and now I want to use the volume displaced, so it's 2.93 times 0.0293, and then times the density of the fluid, right? Okay, so this is my volume. I actually did volume times density, and then that is 893. Ta-da. Okay, so 0.13 times 0.152 times 0.0293. Is that right? Yes. Times 893 is the mass is 0.517018 kilograms. Now, to find the density of the wood, all I have to do is use the formula for density, mass divided by volume. Only in this case, I'm going to use the entire volume of the wood, because that's what you've got to do. Okay, so 0.517018 kilograms, and then divide by the dimensions of the wood, right? This thing, 0.13 times 0.152 times 0.0378. Okay, so now I'm going to divide that guy by 0.13 times 0.152 times 0.0378. 692.19. Okay. Now, how do you woodshed these? Well, there's a lot of stuff to do. Is there a simpler way? Yeah. I don't know if you noticed, but this factor and this factor and all of this, looks like direct proportion. And here's the rule, right? If the thing floats, if it's the same density as the fluid, it's going to float with it entirely submerged. If it's half the density, half will be submerged. If it's a quarter of the density, it'll be a quarter submerged, right? So really, I believe what we can do is we can say density of the fluid over density of the object is, what is that? That's going to be, I'm flipping it upside down. Let's do it the other way. I got to think of it the other way. Density of the object over the density of the fluid is the amount submerged over the total dimension, right? Right, so let's see. The density of the object is what we're trying to find. The density of the fluid is 893. Right, the amount submerged is 2.93, and the amount that it could have been submerged is 3.78, right? Okay, let's see. Does this work? I hope it does. Okay, so let's see. 893 times 2.93 divided by 3.78. Yeah, that worked. Okay. Now let's apply the Jolibois principle to this, right? In this case, it's not going to be a great savings, but it also works, right? We could also say that that the upward force here, right, rho GH times the area, right? This would be the hydrostatic pressure times the area, is the mass of the wood. times G, right? Which, there we have it, right? So 893, and that's just going to give us the mass. That doesn't really help us that much, right? And then we'd have to do all the same calculations. But anyway, that's, this would also work, right? You could work through it that way. I'm not going to, though.